with part B on our discrete random variable video series. This one is for the HL students, variance and standard deviation of a discrete random variable. We've seen how to find the expected value. We can, of course, find out not just the mean, but information about the spread of data. Very useful. You can recall your rule for variance. Take each score, subtract the mean, square it, add each of those multiplied by the frequency divided by n, and you get your variance. That's the word I'm looking for. And there's a few different ways we can write it there. These rules for discrete random variables make it fairly straightforward. You mean the expected value, remember each score times its probability. For the variance, you can do that distribution minus the mean squared and find the expected value of that, which is just finding each score minus the mean, square it, multiply it by its probability. For the variance, or the standard deviation, it's just a square root of that, and we take the positive square root as always. Nothing too exciting there. There is an alternate formula. We'll have a look at the formulae that are in the formula booklet so you can see it later on. Interesting, so you can do each one individually, add them, and then multiply by the probability, or you can just square each x and multiply it by its probability, add those, and then subtract the mean squared. Often this is easier, so it's worth keeping in mind that that may be useful. We're back to our magazine example here. If you go ahead and you take each result, multiply it by its probability, add them together, you're going to get 2.39. I think that example was easy enough. I didn't include it. That's okay. The standard deviation, for each score, you need to subtract the mean, square it, and then multiply by the probability again. So for the first one, I'm going to take 1, subtract the 2.39, negative 1.39, square it, multiply by the probability of 0.23. To that, I then add 2 minus the 2.39, so negative 0.39, square it, multiply by the probability, add it to the next one. Once I've got all of those, standard deviation, I'm just going to find the square root. Calculator steps there for how to do it. You can get list 3 to figure it out for you. This will step you through how to do it, or it will actually just tell you, as long as you say that you've got a frequency list, so your variable's in list 1, the frequency is in list 2, then when you do your one variable stats, it'll actually just spit it out for you as well, which is even nicer. Being able to do it both ways is important though. You're not going to get a big long list of things to do it for, but if you've got a short little table with only 4 or 5 values, doing it by hand will just help you understand what's going on. Again, we've done that sort of thing before. It's not going to be too bad. We had a little look at that sort of stuff in year 10. Properties of AX plus B, where X is a discrete random variable, so it's a distribution probability mass function they refer to it as. There are some little things that are useful here. The expected value of X is the expected value of the random variable. Then the expected value of K, where K is a constant, is just going to be itself. There's no involvement of the random variable, so if I have a number 7, the expected value of the number 7 is 7. It's not really groundbreaking. It can be important for building up rules later on. That's why they've included it there. We're not really going to need it for ourselves. The expected value of K times a distribution. You imagine rolling a die. We've got the numbers 1 to 6 there. If I came along and just tripled each of the values, so we had 3, 6, 9, 12, 15, 18, and then found the expected value of that, it's just going to be 3 times the expected value. So originally when we have 1, 2, 3, 4, 5, or 6, the expected value of that is 3.5. If I tripled each of the values, the expected value is going to be 3 times 3.5, 10.5. Finally, the expected value of 2 discrete random variables, the sum of those two is just the sum of each of their expected values. So again, I could go with rolling 2 dice. Roll the first die, the expected value of that one's 3.5. Roll the second die, expected value of that one's 3.5. What's the expected outcome when I roll 2 dice? You already know that's 7. 3.5 plus 3.5 is 7. So it makes pretty good sense there. The properties of AX plus B are worth having a little explore. You can just have a go at that yourself if you like. Find the expected value in the variance. So that'll give you one little practice that. Well, here we go. What's the expected value going to be? They're all the same. Distributed perfectly. I think we're going to get 0.2. That's not going to be very hard. And the variance, you can go ahead and figure that out as well. Doing those, they want you to discover these rules. The expected value of a linear transformation of a discrete random variable. What does that mean? You've just multiplied it by something and then added something to it. So I tripled all the values on my dice. So I got from 1, 2, 3, 4, 5, 6, I got to 3, 6, 9, 12, 15, 18. And then I added 2 to each of them. whatever that's going to be, that's going to test me out too much. 5 and 8. Yeah, it is, isn't it? 5, 8, 11, 14, 17, and 20 would be my distribution. And I can find the expected value of that by just doing a times the expected value of x and then adding on the 2 at the end. So linear transformations, a is multiplying the x values, so that's what happens. Adding the same amount onto each one is going to have the effect of just shifting the expected value by that amount. Kind of like when we do our transformations of functions, so nothing too dissimilar there. The variance of a linear transformation is going to be a squared times the variance of x, because remember we're squaring all those differences, so if I multiply each x and then square it, I'm going to end up with an a squared in front, so that's why we get the a squared there. And when you square root this, we take the positive square root of the a squared, so that's why they're saying the absolute value of a multiplied by the standard deviation of x will give us the standard deviation of the new transformation. An example's probably needed there because I talked about what we could do and I talked about the example in my head and I'm going a little bit quickly. So let's have a look here. A random variable x has a mean of 8.1 and a standard deviation of 2.37. If y is the linear transformation of this random variable, so it's now 4 times x minus 7. So I've transformed this distribution by multiplying every value by 4 and then subtracting 7 from it. What's the difference? Well, the expected value of y is going to be 4 times whatever the expected value of x was, because that's what happened when I multiplied everything by 4. Then I went and I decreased everything by 7. So once I've got that expected value, I take away the 7. So 4 times 8.1, 32.4, take away 7, we've got our 25.4. The variance, they want the standard deviation, so the standard deviation, remember, is the absolute value of what I was multiplying by, the coefficient of x there. So the absolute value of 4 is just going to be 4. So 4 times the standard deviation of x. If the standard deviation was 2.37, multiply that by 4. I'm going to assume they got it right when they said 9.48. The exercises won't be too hard. It's a little bit different, but it's nothing complicated. You just follow these rules and it will work out nicely for you. You can see you've got the rules in your formula book there. So there's no reason why you should have any trouble with this. I think you should be able to power through those exercises nice and easily. I will see you in part C when we join back together with the SL kids for the rest of it. Keep up the good work.